Cassini wasn't just a spacecraft, it was a marvel of human ingenuity. Built by NASA in collaboration with the European Space Agency, ESA, and the Italian Space Agency, ASI, the Cassini-Huygens mission was one of the most complex interplanetary endeavors ever attempted. Let's go inside the machine that made history. At its core, Cassini stood over 6.8 meters tall, about the size of a school bus standing upright. It weighed more than 20,100 kilograms, and every gram of that mass had a purpose. Packed within its structure were 12 scientific instruments, dozens of subsystems, thrusters, sensors, and the Huygens lander tucked safely on board. But powering Cassini posed a challenge. At Saturn's vast distance from the Sun, solar energy is practically useless. Instead, Cassini relied on 3 radioisotope thermoelectric generators, RTGs, devices that converted the heat from decaying plutonium into electricity. These RTGs quietly powered the spacecraft for more than 2 decades. Cassini was built to endure extremes: cosmic radiation, frigid temperatures, and the vacuum of space. Its structure included protective shielding, thermal blankets, and a robust propulsion system that allowed for complex maneuvers around Saturn and its moons. One of its most iconic features was its large high-gain antenna, which not only relayed data back to Earth across billions of kilometers, but also doubled as a shield during the dangerous ring crossings late in the mission. This antenna transmitted images, magnetic readings, atmospheric samples, and countless bytes of information at rates up to 165,000 bits per second. Remarkable considering the vast distance. Each of Cassini's instruments served a specific purpose. ISS, Imaging Science Subsystem, captured stunning visible light photos of Saturn, its rings and moons. CIRS, Composite Infrared Spectrometer, measured temperature and heat emission across the system. EMAG, Magnetometer, mapped Saturn's magnetic field and detected interactions with the solar wind. INMS, Ion and Neutral Mass Spectrometer, analyzed gases and particles, including the plumes of Enceladus. Radar, penetrated Titan's thick atmosphere to reveal surface structures never before seen. These tools work together to turn Cassini into a robotic scientist, capable of making autonomous decisions, adjusting course mid-mission, and capturing once-in-a-lifetime phenomena. Perhaps most impressively, Cassini was designed decades before modern smartphones even existed. Its computing power was a fraction of what fits in a pocket today, and yet it operated flawlessly across 1 billion kilometers of space, with no room for error. Every command sent to Cassini, each maneuver, photo, and data burst, was programmed hours, sometimes days, in advance. There was no joystick, no real-time control. Engineers on Earth had to anticipate everything, and Cassini had to think for itself when problems arose. This was particularly true during Saturn orbit insertion in 2004 and the grand finale dives in 2017. In both cases, Cassini had to perform critical burns, flip orientations, and execute science programs all without real-time input. And it delivered, spectacularly. Over the course of its mission, Cassini completed 294 orbits, took nearly 500,000 images, made 162 targeted flybys, and changed our understanding of the outer solar system forever. The spacecraft wasn't just a vessel, it was a symbol of collaboration between agencies and nations, of patience from a mission that took 20 years to complete, and of ambition, because Cassini didn't just visit Saturn, it redefined how we explore. Up next on Infinity Beyond, we'll look at the emotional and scientific weight of Cassini's final act, its deliberate dive into Saturn, and the legacy it left behind in its final transmission.